Hey guys, so this week we're going over organic chemistry, and I will totally admit this was what I was looking forward to. Organic chemistry is my favorite type of chemistry, and if you've had me before, you know chemistry is my favorite topic. So to be in my favorite part of my favorite topic, I love this. I did every single organic chemistry course available to me in college and university. It's so nice to be able to talk about this with you guys. So, organic compounds. Organic compounds are just compounds that contain carbon. And when they contain carbon, they generally contain hydrogen as well. But this doesn't mean all carbon, well, every single compound with carbon is going to be organic. There are some that do not, like our carbonates, our CO3s, our carbon dioxide, our carbon monoxide. Those are not organic compounds. Organic usually it makes it sound like these compounds always come from living things. Some of them do, some of them don't. There are quite a few that do come from living things, though. Okay, so before we get into the nitty-gritty about this, I want to talk about the different ways you'll be able to see them. So this is two pictures of the same compound. This is the exact same compound. This is called a space filling model. This is called a ball and stick model for obvious reasons. There are two different ways you can also see them, is the structural model. Ooh. And the molecular model. So the molecular model just tells us what the elements are. This is basically the formula that we had. So what we do is we look at these drawings, and in this case, black is carbon. In this case, gray is carbon. Our white are hydrogens for both. And our red is oxygen. So we look and see, the ball and stick one is the easiest for us to see. We look and see how many carbons we have. Well, we have two. So it's two carbons. How many hydrogens? We're going to ignore this part right here right now. We're going to count all the other ones. 1, 2, 3, 4, 5. And then we write out this last one, and this last is an O and an H together. So that's our molecular model. That just tells us what it's made up of. Our structural shows us a bit more. So the easiest way to start is, again, start with our central carbons. We have a carbon with one bond to another carbon. The one over here is attached to 3 hydrogens. So this is kind of like the Lewis compounds when we looked at covalent. We're going to show a line as a bond. So we have 3 hydrogens. And then on this one over here, we have 2 hydrogens. And our last one is O and then H. So the only thing this is missing is those pair of valence electrons that are on the outside. But we wouldn't necessarily draw those in a structural model. We may not even show the OH as separate things. We might just show it as OH to show that it's a hydroxide molecule. But all 4 of these things show us the same thing, which is our C2H5OH. So the reason why carbon is so important is because it has 4 electrons in its outer shell. So if you drew the Lewis diagram, it looks like this, which means there are a lot of different things that we can bond to it. And because we have so many options, what can happen is that they can actually bond with each other. This one we only saw 2 carbons, but when we look at like plastics and petroleum, there are actually going to be long lines of carbons that are joined together. And I mean, this isn't even a long line. Sometimes for plastics and whatnot, there's going to be over 5,000 carbons that are attached together with hydrogens and possibly oxygen attached. So they get really, really long. So there are 2 types of organic molecules that we're going to look at. And the first type is called a hydrocarbon. Hydrocarbon, all one word. And a hydrocarbon is organic compound or compounds that only contain hydrogen and carbon. Which makes sense when you look at the name. Hydro for hydrogen, carbon for carbon. So hydrocarbons are based on a carbon backbone or a chain with hydrogen atoms added to the side. So this is when we're going to see our big line of C's. You may also see it as our ball and chain. And if you see it like that, it'll be staggered like this. But this is just the carbons. We also have to put in our white hydrogens. So there are a few that have special names. If we have CH4, so a single carbon with 4 hydrogens, it's called methane. If we have 2 carbons, it's called ethane. 3 carbons, is called propane. Four carbons is called butane. And 5 carbons is called pentane. When we get into the next type, we are going to be looking at alcohols, and you'll find that the naming system is actually quite similar. So all hydrocarbons are flammable. As you can probably notice, ethane and propane and butane even are things that we commonly see. And they're mostly, most of them are liquids at room temperature. Okay, so the other type is called alcohols. And the only difference between hydrocarbons and alcohols is that alcohols have a hydroxide group off their carbon chain. So the simplest one is called, well, it's CH3OH. And that one is a really simple one. It looks just like methane, but instead of having 4 hydrogens, we have an OH group off one. And this is called methanol. So all of the alcohols are going to end in something like -ol. For the most part, there are a couple differences. So then if we take C2H5OH, again, looks just like our ethane, but instead of the last hydrogen, or one of the hydrogens, we have a hydroxide group. And this is called ethanol. One that is different is our C3H7OH. Once you get to more than 2 carbons in a chain, you can actually switch up the position of the hydrocarbon, hydroxide group, because right now there's only really one place to put it. It's going to be off one of these two, and if you flipped or mirror imaged this, it would be in the other one. So there's not a huge difference where you put it in this. But once you have three carbons, there are 3 different placements that you can put your hydroxide group, and that changes its name. So for C3H7OH, we're just going to go with isopropyl alcohol. And this is something you may actually have at home. So alcohols are really good solvents, so they dissolve other substances, and they're very flammable as well. So on your assignment, I expect you to be able to identify which things are organic, which are not organic, which things are hydrocarbons, which ones are alcohols, and then to distinguish between the space filling, the ball and stick, the structural and the molecular formulas, models, as well as be able to identify a compound using one of those models. So just as a reminder, and to make sure that you understand the difference between organic and inorganic. So organic compounds and inorganic. Most of these will contain carbon, but there's a difference between them. So CH4, definitely an organic compound. CH3, CH2OH. That is actually another way to write ethanol. Because if you see here, our CH3 refers to this part, and our CH2 refers to this part, and our OH refers to the last. So it's another way to write it. It's more of a cross between the molecular and the structural. Instead of having all the drawing of the structural, it still lets you know how it is formed. It just takes up less room. C6H5COOH. This is benzoic acid, so it is a organic acid. This one's tricky. Potassium citrate. So it is K2HC6H5O7. So this is an organic salt. So it doesn't look like it would be organic because it starts with a metal, but this one is still an organic salt. We have C8H10N4O2. So this one we throw in a nitrogen, but this is something that I know a lot of you guys enjoy. Caffeine. So even though caffeine has a nitrogen, it's still considered an organic compound. So let's look at some inorganic compounds. So calcium carbonate. Even though there's a carbon in it, it is inorganic because it's a carbonate. Same with our sodium carbonate. Then we have our aluminum carbide. Again, this has a carbon in it, but it's not considered an organic compound. It's considered inorganic. And our silicon carbide. Carbon monoxide and carbon dioxide are also compounds we consider inorganic, even though they have carbons. And then we have some inorganic compounds that don't have carbon in them. These are things that you guys are already familiar with, like iron chloride and ammonium sulfite. So this week's assignment is in our folder on Google Drive already, and just to let